Okay guys, this video will be relatively short. I know sequences can be really challenging, so I don't want to go too fast, too quickly. I know there are some questions today about recursive versus explicit, so let's just focus on a common sequence called a factorial. And you may have seen this before, maybe not known exactly what it was, but let's just jump right into it. So 5 factorial, before I fill in the blank, let's actually go down to the second question where it says, what is 5 factorial? Well, when you see that little exclamation point, what that really is saying mathematically is 5 factorial is equivalent to 5 times 4 times 3 times 2 times 1. It's basically saying take all the numbers from 5 and below, all the integers, I should say, and multiply them together. In this case, 5 times 4 times 3 times 2 times 1 times 1 is equal to 120. So if I were to ask you what 5 factorial is, okay, that's just equal to 120. And I don't have the calculator. Actually, I do. There is a button on the calculator that will do that for us. And luckily I can't find, oh, actually I think I know what it is. So if you go to, where is it? The math button, it should bring up math if you're on the TI-83 or something similar. There's something at the top on the left side, right underneath the alpha button that says math. And if you, once you click it, scroll to the far right where it says PRB, number 4 down there is an exclamation point. That's the factorial. So if you hit the number 5 and then hit the math button and go over to PRB and go down to number 4 where the exclamation point is, it should put an exclamation point in front of the 5 and you hit enter. It should say 120. Now you might be saying, Mr. Botter, I'm just going to do 5 times 4 times 3 times 2 times 1. That's much faster than hitting the math button and going over to PRB and doing it that way. With 5 factorial it is, but if I were to ask you what 35 factorial is or 122 factorial, it might be helpful to know that button because that would take you a long time to do it. Okay? So that's what a factorial is. It's basically the summation of the product of a sequence like 5 times 4 times 3 times 2 times 1. So if we go back to the blank above, it says the exclamation point symbol in math stands for factorial. And really all it's saying is take the number you're given. Let's say you're given the number n. And take n and multiply it by the number 1 less than it, times the number 2 less than it, times the number 3 less than it, dot, 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 all the way down to 2, and eventually to 1. All right, so if you're looking at 10 factorial, it's 10 times 9 times 8 times 7 times 6 times 5 times 4, all the way down to 1 and so on, right? All right, so that's factorial, okay? So here's probably one of the most common questions you will see, okay? And the question is, what is 11 factorial divided by 8 factorial? Now, you might feel tempted to say, all right, what's 11 factorial and find the value. Then type in 8 factorial, find that value, and divide them. Okay, but I'm going to show you a quicker way to do this. Okay, quicker way to do this, and I'm going to show you why that works. So let's remember that if I were to write this out, 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 8 factorial, which we know to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, if we look at it, the top is all products and the bottom is all products. So any common terms among the both of them I can cross out. So I can cross out the 1s, 2s, 3s, 4s, 5s, 6s, the 7s, and the 8s, leaving me with 11 factorial over 8 factorial is really just equal to 11 times 10 times 9, which comes out to 990. So you can see all the factorials in the denominator cancel out, and I'm just left with all the numbers that aren't shared between the numerator and denominator. So let's just try, for example, 20 factorial over 15 factorial. Hit pause for a second and see if you can figure out what that is without actually doing 20 factorial and solving and 15 factorial and solving. Okay, hopefully you tried it. And you should hopefully notice from the pattern above that this would just be equal to 20 times 19 times 18 times 17 times 16, which comes out to, I just made this up off the top of my head, so I'm going to have to do it out, times 17 times 16. Still a big number. It looks like it's 1,860,480. Okay, I'm going to give you one more problem that I want you to hit pause on, and then you can, we'll be done with the video. Let's do 38 factorial over 36 factorial. What would that be equivalent to? Again, I encourage you to hit pause, see if you can figure it out, and then check your answer back with me. All right, 38 factorial over 36 factorial. Well, everything up to 36 would cancel out in the denominator, leaving me in the numerator with just 38 times 37, which we all, of course, know is 1,406. Okay, so that is your factorial sequences. If you remember for homework last night, I had you skip a bunch of problems. We're going to do those tonight. So the problems, from homework number 2 that we started the other day. From homework number 2, you need to do problems 21, 23, 25, and 27. Those are the ones that are circled on homework number 2 that we did not get to the other day. A couple of them could be kind of tricky, especially looking at 27. So be patient with it, give it your best shot, and then come to class with questions next time, and we'll hopefully get them answered.